Hey there, 7th graders. We're going to do lesson 8 of chapter 9 today. I thought lesson 7 was a pretty quick and easy one that I'm sure hopefully made a lot of sense yesterday, and I'm not sure we really need to spend 2 days on that one. So let's move on to lesson 8. We're going to talk about quadratic functions today. You learned about linear functions yesterday. Functions are graphs that make straight lines, right? Today we're going to talk about quadratic functions, which make curves, or the fancy name for these curves are parabolas. And here's the way quadratic functions look. Hey, they have something x squared plus something x plus something without any variable or x at all. Now, you don't need all the parts. The only part it needs to be a quadratic function is something with an x squared. Sometimes these last two parts are missing. Like, take a look at this example. Y equals x squared minus 4. Notice it's missing this middle piece. It doesn't have something x, but it does have something plus or minus at the end, right? And that's okay. All it needs to be a quadratic function is to have this first piece, something x squared. And when you graph it, you're going to always end up with this funky U shape. We'll show you how that works. So the main thing you're going to be doing today is graphing these functions. So I want you to grab some graph paper and do a couple of these along with me, okay? When you do your XY table, here are the values that are going to work most of the time. If you use -2, -1, 0, 1, and 2, you're going to probably be able to see your V shape most of the time, okay? Sometimes one side or the other of the V shape might not show up, and you'll have to add another number or two. I'll show you if that happens what to do, okay? So we're going to put these x values into this x spot right here, okay? Always put it in parentheses. Really important. I'll show you why in just a second, okay? Here we go. So I'm going to rewrite it below, and I'm going to always slide it in parentheses. Okay, so -2 squared. -2 times -2 is 4. Take away 2 is 2. Okay, so let's replace that. If I erase that carefully, and I put a -1 in there this time. Now I have -1 squared, which is +1. Take away 2. So that'd be -1, right? Now if I put a 0 in there, I'll erase it again really carefully. If I put a 0 in there, 0 squared is just 0. Take away 2 would be -2, right? And if I erase it carefully and put a 1 in there, 1 squared is 1. Take away 2 is -1, right? And if I erase it one last time and put a 2 in there, 2 squared is 4, right? 4 minus 2 is 2. So let's graph this thing. Watch how this makes this V shape. We have a dot at -2, 2. Graph this right along with me. We have dot at -1, 1. We have a dot at 0, -2. So down here. Sorry, my last dot should have been at -1, -1. My apologies for that. I made a mistake there. -1, -1. There you go. That looks more like a V shape. There we go. 1, -1. There we go. And 2, 2. There we go. Do you see that V shape? So when you graph this, what you do is you draw a line making that shape, put your arrows on the end, and then you see how we get a V? Kind of cool, right? Let's do another one. You can have fractions before this x squared too. I'll show you how to do those. So what we're going to do is rewrite this. I would suggest you do the same. Do this one with me. Put some parentheses and leave a blank there. We'll keep filling that in with a different number, okay? So first of all, we're going to put -2 where this x is. Let's do according to PEMDAS, we should do the powers and exponents, the parentheses and exponents first, right? So let's do that. -2 squared would be 4, right? And then 4 over 1 times 1/4, right? Because we got to take it now times this 1/4 piece. Well, that would be 4 over 4, or 1, right? So we get 1 if we put a -2 in there. All right, erasing this to get it out of the way. Let's erase what's in our parentheses, and let's replace that this time with a -1. So now we have -1 squared. -1 squared is 1 times 1/4. Well, anything times 1 is just going to be itself, right? So 1/4. If I put a 0 in the parentheses, where the x is, 0 squared is 0. And 0 times 1/4 is just 0, right? So now if we put a 1 in the parentheses, 1 squared is just 1, times 1/4 is just 1/4 again, right? And then if I put a 2 in the parentheses where the x is, 2 squared is 4, right? And then 4 times 1/4 gives us that 1 again, doesn't it? 4 over 4. So there we go. So now let's graph this thing. We have a dot at -2, +1, right? We have a dot at -1, 1/4, so like right here. Barely above that. Okay, and then we have a dot at 0, 0. Then we have a dot at 1, 1/4. So about right there. And we have a dot at 2, 1. Do you see our V shape? This one's going to be a really wide V shape, isn't it? It's going to be kind of more like that. They can be skinny or wide You see that V shape that we end up with? There's our quadratic function. Okay, be careful. There are some tricky ones that have a negative sign hanging out here in front of the x. So here's why parentheses are really, really important. I'm going to rewrite this. I'm going to put this negative sign here. Then I'm going to put the parentheses squared. So notice what's going to happen is everything's going to get made negative by that negative sign that hangs out outside the x there. Okay, now let's squeeze all the x's into these parentheses. I'm going to put negative 2 in there first. Negative 2 squared is 4, right? Positive 4. But then we've got this negative sign hanging out up here. So it's going to end up being negative 4 anyways, right? Negative 2 times negative 2 gives us positive 4. But since there was that negative sign hanging out right outside the parentheses, that makes it negative again. Does that make sense? So we end up with negative 4. So now I'm going to erase this and put another number in. Let's put negative 1 in. So negative 1 squared, or negative 1 times negative 1, is positive 1. But then it becomes negative again because of that sign, okay? All right, let's put in another number. This time let's put in 0. 0 squared is just 0, and negative sign just makes it negative 0 or 0. That's the same thing, all right? Now let's put a 1 in here. Put a 1 in there. 1 squared is 1, but then there's this negative sign that makes it negative 1, right? Okay. We put a 2 in there. 2 squared is 4, but then there's this negative sign hanging out at here, so negative 4. All right, so let's graph this thing. Watch what's going to happen. When you have a negative sign hanging out in front of the x like that, it turns your v upside down. You'll see that. Negative 2, negative 4 is our first dot. Negative 1 is our second dot. 0, 0, 1, negative 1, and 2, negative 4. Do you see that? We end up with a v shape that's upside down. That's what happens when you have a negative sign right here in front of an x. So watch out. That'll happen a couple times today. How about one more? Do this one with me. What I would have you do is rewrite it again like this with a blank where the x is, and then keep sliding in those pieces. This one's got a couple of pieces, so it's a little different. So notice, if I slide that in there, okay, negative 2 squared is positive 4. Then we got to take it times this 2. 8 plus 1 more, 9. Do you see how I got that? This one's got a couple different pieces. So now I'm going to erase what's in the parentheses, and we're going to put negative 1 in there this time. Negative 1 squared is positive 1 times 2 is 2 plus 1 is 3. See how I got that? Let's do another one. Erase what's in there. This time we're going to put 0. 0 squared is 0 times 2 is still 0 plus 1 is 1. See how I'm getting these numbers? Erase what's in the parentheses again. Let's put a new number in there, positive 1. 1 squared is 1 times 2 is 2 plus 1 is 3. Erase their number. This time we're going to substitute in a 2 for x. 2 squared is 4 times 2 is 8 plus 1 is 9. Okay, so now if I graph this, notice negative 2, 9. That's way up our graph here. Negative 1, 3. 0, 1. 1, 3. And 2, 9. And if I connect my nice dots I just made, we end up with this beautiful V shape, our parabola. They're going to give you some real-world problems like this today. So I want to do one of these with you because they're going to have just one that's exactly like this in today's work, okay? So here it says Jeff threw a baseball in the air. The equation that gives the ball's height in meters, h, here's the height, as a function of time is this. T stands for time, okay? Interpret the graph. What values of the domain and range are reasonable? Okay, so we're going to make a graph here. And remember the values that we've been using this whole time, x, y. We've been using negative 1, or negative 2, negative 1, 0, 1, and 2. Let's use those same ones to see if we can get our V shape, okay? And let's see how this works. Here we go. All right, let's rewrite the equation down here where we have some room here. So negative 4.9 times t squared. I'm going to leave that blank. We'll call our x's our t. Okay, x will be our time. So think of x as being t. Plus 16 times our x, or our t, plus 1.4. Okay, so let's put in, remember our t, time, always goes on the x-axis. So let's think of that as our x's. So we're going to put negative 2 into these two spots this time, okay? And that's going to help us get our answer. Let me pull this up just a little bit so we can have some more room down here. Okay, negative 2 squared is positive 4, okay? And then you're going to take that times negative 4.9. So I'm going to do that right now on my calculator I have sitting out right here. So I'm going to do 4.9 negative times 4. So we get negative 19.6, okay, for these two pieces right here, plus 16 times negative 2, so plus negative 32, right, plus 1.4. You may type this into your calculator. So negative 19.6 plus negative 32 plus 1.4. So we get negative 50.2. Going to be some bigger numbers. Tell you what, let me do this in black so it stands out better. Negative 50.2, okay? All right, let's do the same thing for negative 1. So I'm going to erase all this. I'm going to erase what's in the parentheses here, if it'll let me. There it goes. Okay, and let's replace all those spots now, those t's, or our x's, with negative 1 this time, because there's two spots where there are t's, okay? Negative 1 squared is positive 1 times 4.9 would give us negative 4.9 still, right? 16 times negative 1 would be negative 16, right? Plus 1.4. So let's pop that into our calculator, those three pieces. We get 4.9 negative minus 16 plus 1.4. We get negative 19.5. Okay, let's erase and let's put a 0 into both of these spots this time. We'll get rid of all this. You can do the same. Hopefully you're doing this one with me. We got one like this in our work, okay? So join me on this. Oh, that's way too thick here. Let's fix that. Undo that. And this time, there we go. I don't know why I've got gray all of a sudden, but we'll go with it. All right. All right, 0, 0. So if I put 0 in those spots, come on, why do I have gray? That's really bizarre. Let's try that again. 0, 0. I guess we're going gray today. All right, that's okay. All right. 0 squared is just 0. Hey, to my black speck. 0 squared is just 0 times negative 4.9 is still 0. 16 times 0 is 0 plus 1.4. I think you know the answer to that. We just have 1.4. All right, let's put 1 into both spots this time. Here we go. Erase. Maybe. There it goes. Technical difficulties today. All right, we're going to put 1 into both of those spots. 1 squared is 1 times negative 4.9 is just going to be negative 4.9. 16 times 1 is 16 plus 1.4. So let's add those up. 4.9 negative plus 16 plus 1.4. I'm just popping that into my calculator. I'm getting 12.4. Hopefully you're getting the same thing. All right, last one. I know this is a lot of work. We're almost done. Almost done, almost done, almost done. Let's put 2's into those last spots. Thanks for sticking with me. Okay, 2's. 2 squared is 4, and 4 times negative 4.9 is, popping that into my calculator, 19.6 negative, right? Plus 32. That's because I know it's 16 times 2 is plus 1.4. So let's add those up. Negative 19.6 plus 32 plus 1.4. Popping that into my calculator, I'm getting 13.8. All right, we're going to graph this thing, okay? Now, we'll note, is there going to be negative seconds when you graph? No, you're not going to have negative seconds. So we could really just start with 0. So let's make an XY chart, okay? And we'll start with 0, 1, 2, and so on, okay? And so when we graph this thing, 0, 1.4, we have to go all the way up to, if we're graphing these three, 13.8. So maybe we should go by 2's, 2, 4, 6, 8, 10, 12, 14. I think that'll give us a good number. So 0, 1.4. Makes sense. If someone's holding a ball, it's going to be held, a meter or so in the air, right? 1.4. And then 1, 12.4. It's going to hop way up. So about right here. 2, 13.8. So, whoops, sorry, I got that on the wrong line. Let's move that over. 2, 13.8. So notice it's kind of going like this, right? And eventually we know it's going to come, it's going to go down. And if we had kept graphing this thing, it would have gone like this. I should have done a few higher numbers, but we're going to get to the real life one. You're going to get this V shape, right? Because if you throw a ball into the air, it eventually comes down, right? And so then it says interpret the graph. And so in other words, you can say, oh, the ball made the highest height after 3 seconds or 4 seconds, and it fell to the ground after 8 seconds or whatever, okay? You can interpret it that way. And notice letter B. What values of the domain and range are reasonable? Domain are your X values. Range are your Y values, okay? So let's answer the first question first. What values are reasonable for our X values? Remember, our X values were time. Would we consider negative seconds? So you'd say all the positive numbers, right? We wouldn't consider the negative numbers. We can't have -1 seconds or -2 seconds, so we wouldn't consider any of the negatives over here on the x value. How about the y-axis? That's your range. That's this. Can the ball go below the ground? Is it going to like go into the negatives for heights? So wouldn't we say we're going to consider all the positive, I should say x's for this last one, and all the positive y's, right? We're just concerned of how far high up the ball goes. It's never going to go below 0, right? And so does it make sense? That's what they're asking in the question. What parts of your graph would you ignore? Okay, what parts are reasonable to use? We would use the positive x's, right, our positive seconds, and our positive y's to show the heights. Hopefully that makes a little bit of sense. Let's do a few out of our assignment today. I know this is going to be a longer video. Thanks for sticking with me. Let's do a couple out of the assignment just to get you going, okay? So again, for these, what I would highly recommend doing, join with me now. This is your real assignment. If you haven't been joining me yet, join now for sure, okay? I would rewrite the equation like this with the parentheses in a big open space where you can keep erasing those numbers and putting them in. Make an XY chart or an XY table like I have to help you organize these numbers, okay? And these are the numbers you usually want to use today. Those will work most of the time, okay? So let's put in our first one first, -2. -2 squared, -2 times -2 is +4. Now take that times 2. We're going to get 8, aren't we? Okay? So let's erase and replace. This time we're going to put -1 inside here. -1 squared is 1, right? -1 times -1 is +1 times 2 is 2. Okay, let's erase and replace. Do the same thing as I am. Put a 0 in there. 0 squared is 0, and 0 times 2 is 0. So we end up with 0. All right, erase and replace. That's always the best way to do it. You don't have to rewrite it so many times. Put a 1 in there. 1 squared is just 1 times 2 is 2, right? Erase and replace. 2 squared is 4 times 2 is 8. All right, now we can graph. So grab some graph paper, print some off. If you need some, I'll put some on the assignment today. -2, 8 is right here. -1, 2 is here. 0, 0, 1, 2. And 2, 8. See how we get this V shape? Connect all your dots into a beautiful V shape, put arrows on the end, and you're done with number 1. All right, let's do one that's got a fraction in it. Those can be a little trickier. So I want you to rewrite the equation with me. Leave a big open space with a parentheses to put your x's each time, and here we go, okay? Let's put -2 in first. -2 squared is +4. +4 times 1/4. It's going to give you 1, right? 4/4 plus 1. It's 2. See how we got 2 on that one? Let's erase and replace. Here we go. Putting a -1 in here this time. -1 squared is +1, right? -1 times -1 times 1/4. Well, anything times 1 is just itself, so 1/4 plus 1. So we get 1 and 1/4, don't we? Let's erase this and replace it this time with 0. 0 squared is 0. 0 times 1/4 is still 0, plus 1 is 1, right? All right, let's erase and replace. Here goes our 1. 1 squared is just 1 times 1/4. Well, anything times 1 is itself, so 1/4 plus 1 is 1 and 1/4 again. And the last one. Let's put a 2 in there. 2 squared is 4 times 1/4. We know what 4 times 1/4 is. It's 1. We did that before. Plus 1 is 2. All right, let's graph this thing. -2, 2, right? -1, 1 and 1/4, so a little bit above 1, right? 0, 1, okay, 1, 1 and 1/4, and then 2, 2. So you can see this one's going to make a little bit of a wider V when we graph it, okay? Let's do the word problem, number 7. Number 7 here. Join with me. So let's make our XY table. This is like that baseball one, except this one, someone's kicking a soccer ball up into the air. Let's use bigger x values this time because we're not going to do negative x values, right? You're not going to consider your negative seconds into this example. So remember, x is the same thing as t, right? Because that stands for time, okay? And h stands for height. That's our y, right? So let's do like 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds, and so on. And I'm looking at number 7 in our book. I think those are the only 2 things we have to. Okay, what is the height of the ball after 2 seconds? I thought there was one more thing. I'm just going to jot that quick, 2 seconds. All right, well, remember to answer that. All right, here we go. I'm going to zoom out a little bit. There we go. And let's write our equation down here. We've got a lot of space. So -16t squared. I'm going to replace the t squared, though, with open parentheses. Do the same, because remember the t's are the x's, plus 40 times t which I'll replace, sorry, I don't need to actually put the letter t. 40 times t plus 2, okay? All right, let's do 0. If I put 0 where both those t's are, because remember the t's are the x's, 0 squared is 0, times negative 16 is just 0. 40 times 0 is 0 plus 2. So we get 2, right? All right, let's erase and replace everything. Here we go. This time I'm going to put a 1 where those two t's are. Here we go. All right, 1 squared is just 1, times negative 16 is negative 16 for this chunk. 40 times 1 is 40 plus 2, okay? Negative 16 plus 40. Notice different signs, so we subtract them and use the sign of the bigger number. We'd get 24. 24 plus 2, 26, okay? Let's erase and replace again. This time we'll put a 2 in there. Here we go. 2. Okay, 2 squared is 4. 4 times negative 16, I'm going to pop that into my calculator real quick, is negative 64, okay? 40 times 2 would be 80 plus 2. So negative 64 plus 80, notice different signs, so we'd subtract them. That gives us positive 16 plus 2 is 18. Notice the ball is starting to come down now. Our answers that we're getting are a little smaller. Let's do 3. Pop in 3, pop in 3. All right, here we go. 3 squared is 9. 9 times negative 16. That's going to be a big negative number. Negative 144 plus 40 times 3. Well, I know that's 20 plus 2. So negative 144 plus 120. Notice different signs. Use the sign of the bigger number after you add them. That'd be negative 24 plus 2. That would be negative 20. Okay, so let's graph what we've got so far. I think we've got more than enough. 0, 2. Okay, 1, 26. Tell you what, we're going to run out of x values, aren't we? So I'm going to fix this graph. You can do the same. Notice we need to go all the way up to 26. So what if we count by, how about 3s? 3, 6, 9, 12, 15, 18, 21, 24, and 27. So if you want to remake one of these XY charts so it counts by different numbers other than 1 on the Y values, that would be fine. So 0, 2 would be about right there, right? 1, 26 would be a little bit below 27. It's actually right up there. 2, 18. So 2, 18. And 3, negative 20. So this would be 3, 6, 9, negative 12, negative 15, 18, 21. So these are the negatives if you want to renumber those two. So 3, negative 20. So let's see, negative 18, 19, yeah, about right here. Okay, so notice here's our V shape that we end up with. You can connect your dots. Okay. All right. Let's answer the questions based on this equation that we just graphed here, okay? You can remake an XY table or chart like I just did, okay? That gave us more than enough. Letter A says, graph the equation. What's the height of the ball after 2 seconds? So let's look. 2 seconds, we were at 18 feet. So for letter A, put 18 feet, right? Letter B, what values of the domain and range are reasonable to use? So let's put D, remember that's your x values, and R, that's your y values, okay? Which x values would we use? Would we use any of these negative x values? Can you have negative seconds? Remember the x stands for seconds, right? No, right? So we'd use the all positives, right? We'd use the positives for that one, okay? How about the range values? Remember that's your y values. Remember that stands for the height of the ball after this person kicks it up into the air. Can a ball ever go below the ground down here? No, it's just going to stop at 0, right? When it hits the ground, it's just going to stop and bounce a couple times. So we just use all the positive y's would be the ones, all positive x's, all positive y's for the range. Does that make sense? Those are the only numbers that we're going to pay attention to. So in other words, we're only going to pay attention to this part of the graph right here, because this obviously isn't going to happen. The ball's not going to continue on below the earth, and we're not going to have negative seconds. So we're only paying attention to this small part of our V graph right here. That's the only part that really truly makes sense, okay? Hopefully that makes sense. That's your free answer for number 7. So notice 18 feet. And then for letter B, put D for domain. Domain means your x values, okay? All the positive x values are the only ones that make sense. And the range, your R, stands for the y values. Only the positive y values make sense because a ball can't travel below the ground. Hopefully that makes some sense. If not, we'll keep working on ones like that in future lessons, okay? Let me know if you have any questions today as you graph these V's. You may use a calculator. If you get to some of these trickier math problems like these, that's just fine. Okay, don't be afraid to, if you don't end up with a V when you graph it, something went wrong. That's where you might need to reach out to me for help or retry it again. Have a good day, guys.